Welcome for mathematics lesson. We're going to study probability. As you know very well that probability is the numerical measure of a chance. Therefore, we're going to look at mutually exclusive events and independent events. As we know, independent events are events whose occurrence does not affect the occurrence of the other. For example, if you toss at once a coin and a die, whatever shows up in the coin does not affect whatever will show up on the die. So those are called independent events. On the other side, we have mutually exclusive events, and these are events whose occurrence of one excludes the occurrence of the other. For example, if today it rains, then the probability that it will not rain is rendered to be 0. Therefore, such are called mutually exclusive events, events which exclude the occurrence of one another. We're going to consider an example, and you pick the KCSE 2017 Mathematics Paper 2, number 14, a question which was saying that a committee of 3 people was chosen at random from a group of 5 men and 6 women. Find the probability that the committee consisted of more men than women. Therefore, a committee of 3 people is being chosen at random from a group of 5 men and 6 women. Find the probability that the committee consisted of more men than women. Therefore, we can use a probability space or use the tree diagram to represent this information. We are picking 3 people to make a committee from 5 men and 6 women. So what we're going to consider here is the possible outcomes. Remember, in the first selection, we can pick a man or pick a woman, and the probability of picking a man is 5 out of 11. Then a woman is 6 out of 11. Then on the other side, we have the probability of picking a man in the second selection after we had picked a man in the first selection, which means picking a man for the second selection now goes to 4 and it's out of 10. Remember, it is picking without replacement, since a committee member cannot be chosen twice for this matter. Then a woman is 6 out of 10. If we had picked a woman, we still proceed to pick a second time, whereby we can pick a man or a woman. And picking a woman now drops to 5 out of 10, and man 5 out of 10. Now we can again choose for the third time, whereby if we had picked man, we can pick man again or pick a woman, and picking man for the third time now goes to 3, but out of 9. So the other side, because they are mutually exclusive, they must add up to 1. So it should be a 6 out of 9. So in every bracket, total probability must be equal to 1. Okay. We can choose man or woman for the third time, and choosing a woman again drops to 5 out of 9, which means choosing a man will be 4 out of 9. We can again choose man or woman, and picking a man again goes to 4 out of 9, which means a woman 5 out of 9. Then finally, we can pick a man or a woman, and picking a woman for the third time now goes to 4 out of 9, which means picking a man is 5 out of 9. So these are the possible outcomes, and we can outline them at the end of the tree diagram. We have man, man, and man. So man, man, and man. Then we have man, man, woman. We have man, woman, man. Then man, woman, woman. Then after that, we go now to woman, man, 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 man. Then woman, man, woman. Then woman, woman, man. And finally, a woman, a woman, and a woman. So these are the possible outcomes. Remember, we are choosing the probability that the committee consisted of more men than women. So the cases where we have more men than women, remember it should be men and women, then the men are more than women. And men being more than women, this is the first case. This is another case. And this is a third case. Therefore, we have 3 cases where men are more than women. So it will be probability man, man, woman, or probability man, woman, man, or probability woman followed by 2 men. So these are the possible outcomes. The cases where probability of picking a man is greater or there are more men than women. So now we can fix the values whereby we have 5 out of 11. Picking a man again goes to 4 out of 10. Then a woman at the third case. A woman at the third case in that line is going to be 6 out of 9. You can also have probably picking a man, 5 out of 11. Picking a woman in the second case, 6 out of 10. And picking a man again, 4 out of 9. And finally, picking a woman, 6 out of 10, out of 11. Sorry, the first case. Then picking a man is 5 out of 10. And picking a man for the third slot will be 4 out of 9. Therefore, when we multiply all these cases, you find the first case is going to give us, a 5 by 4 by 6. Then we divide by 11 times 10 multiplied by 9. And this is going to give us 4 out of 33. So we add 4 out of 33 and 4 out of 33. This one is going to give us a total probability of 4 out of 11. So that is the probability that choosing men, or the committee chosen, is consisting of more men than women. Thank you for following. Subscribe and share this link with your friends.